what I'm going to show you a little bit is a workflow. As I understood it, you're being asked to provide some trend analysis and some deep dives into some of the, for say, a county government. So you're trying to provide a report that talks about the trend of things that's happening now. So I had sent you this PowerPoint that you're looking at right now. What you're looking at is the average maize growing area for the October rains, defined as P over PET greater than 0.8. So that's the average, what you're seeing on your screen right now, over the 15 years of record. And what I want to kind of just emphasize here is that all of these data are available to really all of Kenya right now. And this is part of the CSA project that's ongoing. So as you look at just this slide, I can then show you a map that says, well, this is how variable things are. And sometimes it's hard to interpret the variability, because here I'm just saying how many years out of the last 15 did in fact that 0.808 P over PET for the 3 months, irrespective of the distribution of the rain. So it's still a little bit even more risky in one sense, but how often was that nominal average at least achieved in the places that are blue, meaning between only 2 years or less out of 15 did it not reach 0.8, whereas the neutral color means 4 to 6 years. And below that, as you can tell, or you would guess, farmers would be really stressed trying to grow maize. Now, when you think about the variability over time, I mean, this is what 2020 looked like. There's just this tiny area around Mount Kenya, whereas 2019 was quite wet in the east, whereas 2018 was pretty normal. 2017 actually dry in the west. 2016 was bone dry in the west and reasonable north of Mount Kenya. And you see this incredible variability year over year, which has an enormous impact on the economics of smallholder farming. So very typically, you start with the map, the spatial, and you're looking for the anomaly. So if you go to the app's web page, what you're able to do when you log in is you can see a lot of data just quickly. So the first place I'm going to go is the interactive maps. And the interactive maps, one of the databases we offer, just because Kenya is a subscriber, is Kenya. And so what this is doing is it gives you access every day to an updated last 30 days, last 7 days, next 7 days map of what's happening with the weather. So it's also the forecast. So what you're looking at right here is the last 30 days have been drier than normal over all of Kenya. And here we are today on June 22nd. So this is pretty significant. Now, it is past the end of the rainy season, but it's been drier than normal anyway. So when you look at the last 7 days, it's likely to be pretty dry. Where things start to get a little bit more interesting, of course, is looking at these maps during the rainy season. So here we are kind of in a drier period, which is okay. You can look at the forecast, drier period. And it's time to do some analysis, if you will, on the trends or the characteristics that the county governments are going to have to deal with. So here is just the rainfall forecast. There's a little bit of rain in the west, a little bit of rain, sort of parts of the country in the forecast, not much, okay? So you might go and download the data. So you click data here, you go to region, East Africa, you pick Kenya, you download it, and you might open it up in QGIS. And I've done this step so I can go and select exactly the file that I downloaded. I'm going to go to work projects on my machine, Kenya. I'm going to go to Colorado, and I've got some data here that I already unzipped. I just downloaded it. I already unzipped it. And let's just look at the last 30 days, bring it in as well-known text, hit add. And the charting or the mapping really is pretty straightforward. I know you guys know how to use this, but what I'm going to do here is just real quickly just give that P over PET. So I'm going to go to symbology, choose this, and I'm looking at the P over PET of the last 30 days. And as I said, the rainy season has already kind of come to an end. So it won't surprise anyone that most of Kenya is too dry really for healthy cropping. Part of the West still has some reasonable conditions, but it is the cool, dry season right now. Also on this map, you see a few dots. These are just some sort of random places. I'm not too worried about it, but those dots, those locations are mapped in a spreadsheet. So here you can see that all I've done is the classic place name, latitude, and longitude. And the reason why these are important is perhaps one of these towns is important to a request you have from a county government. And you're going to go in and dig in and look at these and say, where What are the trends? What's the climatology look like? And so the first two here, up here, you see Choba in the north, and Casarini is here near the Machakos kind of area, down a little bit to the south and east of Nairobi. And that's just to kind of give you 2 place names, number 1 and 2. Okay, so then part of your workflow, you've done the map, you've seen some anomalies or not, but one of the first things you might want to do then is come in and create a climatology chart. Now, the climatology chart itself is an R script. You all know that you can also create the climatology chart here by going to weather apps, okay? And you load the climate chart, okay? And this tool is going to generate the same chart as the R script. The reason why the R script is valuable is because you can run an enormous number of charts sequentially from one script. So if we go back to our location test, what we'll do is we're going to use the latitude and longitude of Casarini, and we're going to create a climate chart. So it's minus 1.4, 37.2. So you load your key and secret. Latitude is minus 1.4. Longitude was 37.2. We're going to call this Casarini. The date range, let's go back, let's look at this last rainy season. So we'll go March 1 to yesterday. We need to change this to 2021 and hit submit. So it's out there pulling the data to create a chart. It looks like it's going to take about 48 API calls is the estimate to do this chart. While it's running, really what I want to explain is we have just taken that R script that we're about to work with to help you guys who are technically competent and able to run sequences of locations. And there's your chart. So I can tell you as an agricultural climatologist, this line right here is 25 millimeters. So the rains in Casarini are supposed to be about 25 millimeters starting about mid-March. It's pretty classic, mid-March onset of the rainy season. Well, this year, there was 0 rain until mid-February when they got about 12 or 15 millimeters. Then they had a reasonable rainfall. So if farmers responded to this, the problem is that they then only had 25 millimeters and very little rain the next 4 weeks. And then you see this odd out-of-season rain here in toward the late May. So probably farmers in Casarini actually had a pretty poor growing season. They are unlikely to make a lot of maize. There just is not enough water, all right? And this has been sort of the tale of this last growing season. So this chart is something that you can do one at a time online, and all you have to know is the latitude, longitude, and whatever name you want to give your location, okay? And here you have it. You can right mouse click, copy that image, and you can paste it into your PowerPoint. So if I wanted to, I could take it here, and I could put the chart right on a PowerPoint. That's as easy as that. You could make your report. You've got your maps, and you've got your chart, okay? So the advantage, though, of the R scripts for you two, or for the people who are listening to this and want to run things with a little bit more expediency, is I can go to a climatology chart script, which are freely available, okay? And obviously you have to start at the beginning. You have to install things. So once you're installed and you have the aWhere charts and libraries, you only have to do this once. Occasionally you have to update it, all right? You have to then load these individual libraries, and you have to install the libraries as well. So I'm assuming you guys are set up to run your R script. So I'm going to make sure all the libraries are loaded, and they are. And then you have to put your credentials file. Now, this credential file is just the key and secret that you can get from the API. You go to your API, you get your key and secret, and you paste that into a text file. Reset it so I won't go there. You take that, you paste that into a text file, and you just link to it. So when you run this line, it's going to tell you that it got a token. And when you get a token, it just means you can continue your work. All right, so I'm going to send you these scripts, okay? I'm going to email these to the two of you today, and you're welcome to share them. They're my working scripts. So as you can see, I have different projects. So you may have a project for one county government, you may have a project for Colorado, you may have another project, and you may have different folders where you store that data, and I would encourage you to break things up that way. So I do that. So I have Global Project USA, and here's a Kenya Colorado. So I'm gonna select which line of code I want to use right now in this particular session. So I'm gonna change the working directory to Colorado. This over here, you see my working directory is Colorado. I'm not going to run these other lines of code. And then I'm going to skip down, right? And I'm going to set the directory. And I see that, in fact, it made the directory the call row. So I'm in the right pointer. Now, the first time you do this, you have to run these scripts. So if I go over to where I am, here's my call row, etc. There's that spreadsheet I already showed you right here with a bunch of place names in Kenya. And that's all you have to do. You can just add a new one, like, Kitui or Mombasa or something like that. Anywhere you want to go for your work, you can just add it. This line of codes right here are going to make some directories. If you already have them and you run it, it won't hurt anything. So I have a charts directory. I have a couple charts in there just to kind of get going. I have a data directory, and you saw where I loaded to QGIS. I downloaded the zip file and made a map. I have figures, which is empty, and output CVS, which is empty. Okay, and so then back to R, and I'm saying, okay, down here, I have a file called locations call row. It's the one that's in this in the spreadsheet. See, locations call row, and it's located. If you want to go to, it's located at Work Projects Kenya call row, which is the folder I already told R where to look. So I can load this as a variable. Locations file is going to be called that. Now I don't run these two lines because there's some other work we're doing. Here's a organization called Chorus or Corn Belt, some USA stuff I was doing. Now I need to set and read that file into a data frame called locations, and I run it, and you see up here I now have locations loaded. I'm going to check it, and I'm going to make sure the place name is correct. And the reason I do that is because occasionally when you use a spreadsheet back and forth, even if you use it as a comma delimited file, sometimes for whatever reason it messes up the first column name. If it's messed up a little bit, then you run this line of code, and all you're doing is you're saying, go into the data frame locations into column 1 and name it, call it place name. It has to be called place name because that's what the R script is expecting. I don't even need to run that. Okay, then here what I'm doing is I'm going to set the historical data to be the long-term normal to be calculated from 2006 through 2020. So I run that, and you see over here my years are 2006, 2020. I'm going to start my analysis on February 1st. I could probably change it to March 1st, but that's fine. This is just the weekly rainfall, so I run that. And I'm actually going to run it through the date of my laptop, meaning as character systems date, and I'm going to go out 14 days. So I'm actually going to include the forecast. So I've just run that one. That's all I've done. So I ran line 135, and I ran line 140. You could run 135 and then just run 136 and pick an end date. You could just say, no, we're going to end it, May 30th or something like that. All right, so then you combine them into this vector. I'm going to set my Y maximum to be 125. Now I set the Y maximum. It'll dynamically do it online. But with this, I set it to a number because I want to compare every chart as exactly the same Y-axis. Otherwise, the bars will be at the same height will mean different things. And that's hard to visually then do the comparison. So I'm going to set it to 125. For the loop reason, I do number of stations, and then I reset a counter. Now, if I want to run all of the rows of this spreadsheet, meaning all of the rows of the data frame. So this is all of my locations, okay? They're all here, 14 of them. You could just run it right there. Now, for the sake of expediency, I'm just gonna run one or two of them. You see this red X? What that means is that there's no closing symbol here. That's the loop. There's no closing loop. And the reason why there's no closing loop is because it's actually closed by this one, but it's only gonna run the first and the second row of my locations data frame. Now, obviously, guys, you could run the 13th through the 19th row. You could run the 5th through the 7th. You could run just the 6th one. You could do 6, 6. This is just a way to do it. So what I'm going to do is I'm going to change this. I'm going to run, let's go get number 3 and number 4. So while it's running, I've already generated 1 and 2, and I'll just show you that. So then I just put the cursor right there, and I hit run. And down here, you're going to see it churn away. It's going to go create the charts. But while it's doing that, I'm going to go to the charts folder, and here you see the first two. There's Choba and there's Kasarani. So if I go to Kasarani, just like we saw online, we started March 1st, I think, online, not February. Rains came early in the east, much more wet than expected, so farmers may have planted. If they planted, it then did not rain at all, really, in March. Okay? And then you see this this bit of rain that showed up. Remember we talked about that in mid-March. And then you see April starting, and there was that one big rainfall event, and then no rain. And then a very, very large wet week in mid-May. Okay, and this has got to be frustrating to the farmers. This is actually one of the most dramatic impacts of climate change, is the increased variability. But what I want to do is say, well, look at this hole in the rainy season. You see that hole in the rainy season? Let's just say it's April 7th to April, say, 30th, 3 weeks. Let's go see if there is a trend in Kasarani for the rains. Kind of what are they doing in late April out there in Kasarani? So that's the trend. So if you're doing something for the government of the county where Kasarani is, you may want to look at it. Now, let's take a look at these other two locations just for fun. So here it is in Curie, and here it's a much wetter location and hardly any rain. All right, now I don't actually know where Curie is. Let's take a quick look. Glancing at the map, it's up here. It looks like it's northeast of Mount Kenya. Curie is up here. So normally, Curie gets pretty high rain, weekly averages of 80 and above 100 millimeters. And this year, they got pretty good rain, really dry, pretty good rain, dry. They may have done okay because, you know, the crops don't need, they need enough water. But if you get 40 millimeters and a bit of rain, and then 100 millimeters, 80 millimeters, a bit of rain, they may have done okay up there growing some of their crops, okay? Because that's part of the analysis and the interpretation. But back to Kasarani. So let's take a look at the trend in Kasarani from, and I've not run this chart, so I don't know what I'm gonna find. So we go back to R, we shift over to the trend charts via API. So let's go up to the top, let's take a look. Once again, you have to have things installed. I'm gonna reset everything just to kind of delete all this to make sure, you know, whatever, there's no monkey business going on, nothing, you know, the environment is empty. I'm gonna make sure all the libraries are loaded, and they are. I'm gonna load my credentials, so I got another token. I'm gonna set my directory to Colro. Okay, if you need to run these lines, you can. Here is that file that has Kasarani and the other 14 locations in it. I read them in, I pop up, open it up, and I know that Kasarani is number 2, okay? So this takes a bit longer to do, so I'm gonna do the regression line. Now, we said we wanna look at about April. We wanna look at the trend between April 8th and April 30th, right? So just changing this, and then I'm gonna basically call it, well, I'll just say 8 April, 30 April, very specific. And that's just the title of the chart. Okay, once again, I've got a number of locations in there. See, the number of locations is 14, but I don't want to run it from 14. I really just want to run Kasarani. So I'd say change it to number 2. And while this is running, I want to express a couple things. So first of all, for my work, I typically, unlike the one online that also includes temperature, I have turned temperature off. And you can come up in here in the script, because you're running it from R, and you can actually turn the temperature back on if you want to, as one of the variables to chart, okay? And that's just, this code is, I'm not gonna go through it in detail, but you have the ability to adjust and change really all of the things that you need to change if you wanted to. But for the most part, what you're asking it to do is run from 2006 through 2021 for that window of, what was it, March 7th through, or sorry, April 7th, at the end of April, and you can see it's pulling all the data quite systematically. And in the end, what you're going to get then is this rainfall chart that will show the trend of the total rain for that 3-week period over the last bunch of years, okay? Excuse me. It should write the chart in here, and there'll be 4 charts it produces. Now, this same chart you can run online doing exactly the same steps, only this time it's climate trend. So I could have just gone right here and done exactly the same steps that the R script is doing, with the advantage that the R script, I could actually get it to run a whole bunch of locations sequentially. So if you go grab a cup of coffee, you would come back, and there'll be a bunch of these available to you. In fact, why don't we do that when it finishes here? just to show what'll happen here, it's about done, is I'll go run, I'll do some trend charts for 4 or 5 others or something like that. It takes a little while, but while it's doing that, we can look over what's happening. So here you see the 4 charts it just produced. So take a look at this. So here is the precipitation trend for Casarini in April. Basically, there is no trend. That's what you want to conclude. However, the CV is 71%. It's hugely variable year to year. And that's what you're looking at. So 2021 was as bone dry as 2014, 2010, and 2011. And one of the other charts you can look at is P over PET. So P over PET, again, there's a slight trend toward increasing. The average is about 1.8. So typically, on average, these guys should be able to produce corn. It's good rainfall for corn there. However, or maize. However, you can see 1, 2, 3, 4, 5 of the last 16 years, the P over PET for that 3-week period in April was actually closer to 0.5, which would be really too dry. The maize would do poorly then, okay? But this is actually quite important to know. It's important to know that, look at the variability. So here the variability kind of bounces like this, then it starts bouncing higher and higher. So the year over year, the variance is quite high. So the interpretation is that these people need augmentative irrigation, because basically 2/3 of the time they're going to need to, if they had access to a little bit of water, they could probably pretty reliably produce good yield, okay? So once again, if I go back up here, rather than entering all the information one at a time, I could just come right back up to this loop here, and let's just run it. I'll run it for number 7, and we'll run it to number 8. So we're going to run, let me get it started. And we'll look at locations. So what we're running now is Mungatsi, and Ngara, okay? And they're just running in the background while this is why we're, in a sense, I can take some questions if you guys would like, and it'll just throw everything into this charts folder automatically because I set the folder to be Calro. And so really the question is to the 2 of you on this particular recorded training is, what can I show you to help you do this task that you've been challenged with, is what is going on in different counties in Kenya, and how can you develop, if you will, a report that would give advice, frankly, to policymakers about how to manage and do a better job of supporting smallholder agriculture. So do you have any questions? Okay, well, if there's no question.
No questions from me.
Oh, go ahead, yeah, Norris.
No question from me.
Okay, so one of the things that you may have to build is this spreadsheet of locations, right? So there's a lot of ways to do this. Now, obviously, you guys have maps of Kenya. You could zoom in using the background. Here, I'll turn this off. You could use QGIS. You could do things like turn on the Google Maps where you see more of the locations here. I could turn off my list of locations. And what you all could do, like here's Kisimu, we've got Nairobi, you've got Kitui out here. One of the things you can do to make a collection of latitude, longitudes while this thing is running is you can just go to select features when you're highlighting one of the aWhere grids. And you can come over and you can say, well, let's pick a location out here. Actually, I think I have to turn this on. I'll do it that way. Yeah, there it is, it's on. Okay. And then I'm holding the control key, and you could grab, someplace in the west, someplace up here, maybe someplace toward Embu, maybe someplace toward Meru, someplace in the valley, maybe Naivasha here, the Rift Valley, and Nakuru. Okay, so I've just collected a set of locations. See those yellowed squares? Then you can go over to Layer, and you can do Save As, and you say Save Only Selected Features. What I typically do is deselect all the data, because that's all the climate data, and all I want is the location ID, the latitude, and the longitude. You got to give it a CSV and where you're going to save it. So I'm going to go to Work Projects. I'm going to go to Kenya. I'm going to go to Calro, and I'll just call this location set. I'll call it Lokes Sample 1. Okay. And so what I'm doing is I need to turn all that off. I don't want all that. I just want that. Latitude, longitude, and I say OK. So I just wrote a file from selection of locations. I come over here, Lokes Sample 1. And you notice that in this one, it's giving you the location ID from the aWhere file, which is not useful. So you may have to do 2 steps here. First one I always do is I change this back to place name. But again, you can do that programmatically in the script. And then you want to go back and you want to change all of these to their actual town name, I would think. But if you go back to QGIS, what's kind of cool about what we just did, just those simple steps of saving it to a CSV file, I can load it. So if I go here and I navigate loc sample, and you notice it's a point coordinate, I hit add. Let me turn off Google because it's a little hard to see with Google Maps, and I'll turn Esri, and you can see my locations now. So I just made a real quick and dirty way of gathering those locations, and then I can run that location set as part of this R script right here by just loading loc sample as my locations file name. So I could change it there, and I could load it, and I would run those, and the name of the file would actually be that numerical value. Back to what we've just generated in charts, and here you can see we've got Wagatsu, and here we've got Ngata, and once again, there's not a big trend, a little bit of a trend here in rainfall for Ngata. You can see there's a trend. It's not statistically significant. That needs to be smaller than 0.05. But you also see that the variability year over year seems to be increasing, which can drive people crazy. This rainfall chart is above 100 millimeters, so it's well watered. If you look at P over PET, again, it's above 1 most years, but not this year. It was down to 0.5. So once again, look at this. The P over PET, 1, 2, 3 years about 0.5, and then these two about 0.8. So you're talking between 3 and 5 years out of 16, where at Ngata, the system would be a little bit too dry. I'm going to kind of see where Ngata is. Let me find my locations that I've been using. Let's see here. Ngata's right there, so it's just near Nakuru. So normally it gets enough rain, but about a third of the time, actually, it's too dry. Again, augmentative irrigation may be a recommendation. Okay, so that's a very quick. We're about out of time. You saw how back to R, you can use R to run a forecast table. You can just run it all at once. It's kind of cool. It's pretty fast. You can run and create a weekly climate, a weekly rainfall chart. You can add temperature if you want, and you can do a trend analysis. So are there any questions right now? And then we'll wrap this up because there's a quicker training, but it's a bit of a workflow where you start, you look at the year over year. You might create a sequence of maps like I did here. Let me delete this chart, but you can see I saved the chart there where you see the rainfall for Pasadena. And you can, you're seeing the change over time. You figure out what the anomalies start to look like, and you start to run charts that will give you a look that gives you information that you can put into your reports. With that, I'll just sort of stop. I'll take any questions, but maybe we can stop the recording, and this will be a good training for you guys. So any questions?
No, for me, it's just saying thanks. Thank you so much. I have learned so much, especially on the chats. I appreciate.
Well, good. Good. All right. Well, so David, why don't we stop the recording?